All right, today we're going to tackle a huge topic that you hear about everywhere, machine learning. So what is it really? What's all the buzz about? Let's break it down and get right into it.
Okay, let's start with something you probably see every single day. You open up your email, and somehow it's already sorted out all the junk from the important stuff. How on earth does it know the difference?
Well, it's not magic, and it's definitely not some person manually checking your inbox. The answer is a really powerful technology called machine learning, and it's quietly working behind the scenes in, well, pretty much every part of our digital lives.
So what is it exactly? At its core, machine learning is really just the process of teaching computers to learn from experience, just like we do. But for them, that experience is data. And the key phrase here, the part that's so important, is without being explicitly programmed. This means instead of a programmer writing a million lines of code with specific rules, they let the machine figure out the rules for itself.
And this is where machine learning completely flips traditional programming on its head. See, normally, a programmer writes the rules, feeds in some data, and gets an output. But with ML, you give the computer the data and the answers, and it actually works backward to figure out the rules on its own. It learns the logic. And the best part? It gets smarter with every new piece of data you give it. That's the real game changer. So how does a computer actually learn anything? It's not just some magic black box. There's a really clear, repeatable process. Let's break down that learning cycle. It all starts with data, and usually a mind-boggling amount of it. Then, a program, which we call a model, gets trained on this data to find patterns that humans might completely miss. Once it's learned these patterns, it can start making predictions on new information it's never seen before. And here's the most powerful part. The cycle just keeps repeating. More data means the model improves, making it this continuous loop of learning.
To make this a little less abstract, think about it this way. You don't teach a toddler what a dog is by giving them a dictionary definition of fur or tail. Nope, you just show them a bunch of pictures, point, and say dog or not dog. Over time, they start to pick up on the patterns themselves, the ears, the snout, the way they wag their tail. Machine learning is basically that exact same process, just with a computer and a whole lot more pictures.
Now, not all learning is the same. Just like students in a classroom, machines have different methods for learning, depending on what problem they're trying to solve. And there are three main flavors of machine learning. First up is supervised learning. You can think of this as learning with an answer key. You give the model a bunch of data that's already been labeled with the correct outcome. For instance, you could feed it thousands of house listings with both the square footage and the final sale price. The model's job is to learn the relationship between the two, so it can then predict the price of a new house. Next, we've got the complete opposite, unsupervised learning. Here, there are no labels, no answer key. You just give the machine a giant pile of raw data and ask it to find hidden structures all on its own. A classic example is customer segmentation. A company can analyze thousands of purchases to discover natural groups of shoppers, all without telling the machine what kind of groups to look for. And finally, there's reinforcement learning. Now, this is learning by doing, pure trial and error. An agent, or model, takes actions in an environment to try and achieve a goal. It gets rewards for good actions and penalties for bad ones. Think of an AI learning to play a video game. At first, it has no idea what it's doing. But after millions of attempts, it learns the perfect strategy to win by maximizing its score, which is its reward. Okay, so we've seen how machines can learn in these different ways. But where does all this fit into the bigger world of technology? You hear terms like AI and machine learning thrown around all the time, so let's clarify that relationship.
The easiest way to think about it is like a set of Russian nesting dolls. Artificial intelligence, or AI, is the biggest doll. It's the overall, broad concept of making machines smart. Inside that doll is machine learning, which is a key method for achieving that AI. And then, even deeper inside, is deep learning, a really specialized type of ML that uses complex structures inspired by the human brain. So, all machine learning is AI, but not all AI is machine learning.
And really, I'm not exaggerating when I say this. Once you know what you're looking for, you start to realize that machine learning is a fundamental part of our modern world. It is absolutely everywhere. In the world of finance, it's like an invisible security guard that's analyzing your transactions in real time. You ever get that text from your bank about a suspicious purchase? Yep, that's an ML model that spotted a pattern that didn't quite look like you. In healthcare, the impact is just incredible. ML models are now analyzing medical images to detect diseases like cancer, sometimes earlier and more accurately than a trained human eye. They can also sift through patient records to predict who's at the highest risk for certain conditions, which is a huge deal for preventative care.
And of course, it's all over our daily digital lives. The reason your favorite shopping website seems to know what you want to buy next, or why your social media feed feels so perfectly tailored to you, well, it's because machine learning algorithms are constantly analyzing your behavior to predict what you'll find most interesting.
We've covered a lot of ground pretty quickly, so let's just bring it all together and boil it down to the most important parts. What's the main thing you should really remember from all this?
So here's the big picture. Machine learning is all about teaching computers to find patterns in data, often on a scale that no human could ever manage. By learning these patterns, they can automate really complex tasks and make predictions. And ultimately, it's this ability to learn from data, not just follow instructions, that makes it the core engine driving the entire AI revolution.
And that leaves us with one final big question to think about. This technology works by analyzing the data we create every single day, our clicks, our purchases, our photos, our words. So as these systems get smarter by watching us,